Now we come to an area which is the nemesis of many chemistry students that we call dimensional analysis. It is also sometimes called unit conversion, and so it's just a method of problem solving in which units are carried through all calculations. Dimensional analysis ensures that the final answer of a calculation has a desired unit. So let's just say that we measure a distance in miles and we want to express that same distance in feet. Okay, that is a weird F. So we're given miles and we want to simply express that same dimension, that same unit of length in feet. And so dimensional analysis is a pretty slick technique that we use to make those determinations. So let's go ahead and do that. So first of all, how many seconds are there in approximately 18.02 hours? So we are starting out in hours. We have 18.02 hours. Apply the appropriate significant figures rule. So what we're saying is that 18.02 is a measurement. It's not an exact value. So significant figures rule applies. So the first thing that you want to do is you want to determine what is the unit that I'm going to, and that is going to be the how many, how much. So that's what you're looking for. You're looking for that, and I call that the X factor. And the X factor, it's like a treasure map. Every treasure map has X marks the spot, and so we're going to X seconds. And then we set an equal sign. So this is our ultimate destination, is the X factor, and in this case, it's X seconds. What goes on the other side of the equal sign is the other principal value that you're given, and it's pretty simple. It's given to you as 18.02 hours. Now, here's the deal. I can express any value as a ratio if I put it over 1, even if there isn't another unit over here. So now I have a numerator, I have a denominator, and now I'm going to come up to my first conversion factor. Now, my conversion factor wants to cancel hours and it wants to go to some smaller unit. So I'm going to go from hours to, and I can't go directly to seconds, I could, but let's keep it simple. And let's go to minutes, because most people know how many minutes there are in an hour. Now, we're going to go back to our conversion factor rule and ask ourselves which one of these is the larger unit. If you remember that, we did that with the metric system, and the larger unit here is hours. So in this particular case, we're going to give hours the 1, and we're going to give minutes the larger number because it's the smaller unit. So hours is the larger unit, we give it the 1, and there are 60 minutes in 1 hour. Now you'll notice that this is going to be multiplication and division. So we're going to multiply across hours times minute and then divide by hours. That's going to allow us to cancel hours, and we wind up with minutes in the numerator, and that's where we are right now. And then we're going to go to seconds. So we'll just draw another line here. We'll come up with minutes. We want it to cancel, and we want to go to seconds. Minutes is the larger unit, so we're going to go ahead and give it a 1, and there are 60 seconds in 1 minute. When I multiply and then divide across, minutes will cancel, and that leaves me with my X factor. My X factor is seconds, and seconds is the only unit that's left. It's in the numerator where I want it to be, so I'll have seconds over 1, and so now I can just multiply and divide across. Now, in your calculator, it's not going to make any difference with this particular calculation because it's pretty simple. My suggestion is you multiply, you're dividing by 1 here, but then you multiply and then divide. And then you multiply and then divide. And that's going to get you where you want to go. So we're going to have seconds. Now the next question is, how many significant figures do we have? Well, this is all multiplication and division. So if you remember your significant figures rules from the last video, we have 1, 2, 3, 4 significant figures. So we're going to want 4 significant figures in our answer. So I plug this in my calculator and I come up with 64,872 seconds. So 64,872 seconds. But hold on here, we're only allowed 4 significant figures. This is 5 significant figures, and so I have to go ahead and round this to 4 significant figures, and I could write this as 64,870, but I think in this case writing it in scientific notation is a cleaner way to write this. So I move the decimal place 1, 2, 3, 4 places to the left. That gives me 6.487 times 10 to the positive 4 seconds, and that is going to be my best answer. And so check. All right, let's go. How many kilometers are there in approximately 26.1 miles? So the how many is my X factor, and that's going to be kilometers. So my X factor in this particular case is kilometers. Now, I'm given 26.1 miles. I've got to get out of the miles system and into the metric system, and whenever you're required to do that, you'll get a few clues that will help you out. So here we go. We're going to kilometers. That's our X factor. What's on the other side is 26.1 miles. And I can go ahead and put that over 1 if it makes me more comfortable canceling my units, but I don't necessarily have to. But let's go ahead and let's put our first conversion factor. Miles is in the numerator, so I want miles in the denominator. And I can go from miles to feet using this conversion factor. So this is going to be feet. Miles is the larger unit, and I've got 5,280 feet in 1 mile. When I multiply across, that allows miles to be canceled, and I wind up with feet. All right, so I don't have a conversion directly from feet into the metric system, but I do have a conversion that will take me from inches to centimeters. So I need to go from feet to inches. So I've got feet down here because I want it to cancel, and then I'm going to go to inches. Now in this particular case, feet is the larger unit, and I've got 12 inches in 1 foot. When I multiply across and divide, feet will cancel. That's going to leave me with inches. So now I'm in inches, and I can use this conversion factor. So I want inches in the denominator. I'm going to put centimeters in the numerator. And this says that 1 inch, inches is the larger unit, and it's equal to 2.54 centimeters. All right, so when I multiply and divide, inches cancel. I now have centimeters. And if you remember from your metric prefixes, we can put centimeters down here, and we can go to meters. Now meters is the larger unit, so it gets the 1, and if you remember, there are 100 or 10 to the second centimeters in 1 meter. When I multiply and divide across, centimeters cancels. I'm now in meters, and now since kilometers is my X factor, I can go directly from meters to kilometers. And now all I have to do is remember that kilometers is 1,000 meters, so that's the larger unit. It gets the 1, and there are 1,000 meters in 1 kilometer. When I multiply and divide across, meters cancels. All right, this is a little bit more complicated. It has more steps to it. It's a multi-step conversion. So when you put this in your calculator, here's what I recommend. You go 26.1 miles times 5,280 divided by 1 times 12 divided by 1 times 2.54 divided by 1 times 1 divided by 100 times 1 divided by 1,000. Now, a lot of people are uncomfortable with that, and so they choose to multiply 26.1 times 5,280 times 12 times 2.54 times 1, and they'll come up with a product for that in the numerator. Then they'll multiply 1 times 1 times 1 times 1 times 100 times 1,000, and they will put that product in the denominator, then do their division. It works exactly the same, but in terms of speed and ease of calculation, doing it this way, going this times this divided by 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 that works exactly the same way, and it is faster. Now, the question is, how many significant figures should we have? And since this is all, once again, multiplication and division, I have 1, 2, 3 significant figures, so my answer will have 3 significant figures. So I'll get 42.0 kilometers, which will be my best answer based on significant figures. Okay, let's go ahead and let's convert 1.74 grams per cubic centimeter into kilograms per cubic meter. Now, it's going to be easy to convert grams into kilograms because kilo means 1,000. Since we're talking about grams and we're going from grams to kilograms, there's 1,000 grams per kilogram. But cubic meters and cubic centimeters are units of volume. So here is a way to think about this. All right, so I'm drawing a cube here, and all right, so we're going to go ahead, and I know this is not to scale, but we're going to go ahead and we're going to say that this is a 1 meter length. And we know from our previous study that 1 meter is equal to 100 centimeters. Over here, we're going to also say that this is 1 meter in width, which is also equal to 100 centimeters. And we're going to say this height is 1 meter in height, and this is 100 centimeters. All right, so you know how to compute the volume of a cube. It's just length times width times height. So this would be 100 centimeters times 100 centimeters times 100 centimeters, and we could do exactly the same volume in meters by saying 1 meter times 1 meter times 1 meter. These two volumes are absolutely equivalent to each other. And so this would equal 100 cubed centimeters cubed divided by 1 cubed meters cubed. These are now exactly the same volumes but they're expressed in different units. This is now cubic centimeters, and this is now cubic meters. And so this is equal to 1, and that's going to be our conversion factor. So knowing that, we can go ahead, and 1 times 1 times 1 is just 1, so we can come up with our x factor, and our x factor is just to do the conversion in kilograms per cubic meter, so that's going to be x kilograms per cubic meter. This is what's known as a derived unit. It's like miles per hour, like a velocity. You have a numerator and you have a denominator. And we start out with the other value, which is 1.74 grams per cubic centimeter. So we have 1.74 grams in every 1 cubic centimeter. And we just want to convert that into kilograms per cubic meter. So here's how you do that. Pick the numerator or the denominator and convert that. Don't worry about the other one. So we're going to do grams per kilogram first because that's pretty easy to do. I've got grams in the numerator, kilograms in the denominator. Kilograms is the larger unit. Grams is the smaller unit because we've got more of them in that 1 kilogram. This will enable us to cancel grams. We now have the numerator, kilograms, of our x factor. All we have to do now is plug in our determined volume conversion. And we've already got our conversion factor. Cubic centimeters is in the denominator, so cubic centimeters here in our conversion factor has to be in the numerator, and cubic meters will be in the denominator. So we know 1 times 1 times 1 is just 1, so 1 cubic meter is equal to 100 centimeters cubed. So this is going to be 100 cubed, centimeters cubed, and then divided by 1 cubic meter. You can see that the cubic centimeters is in the denominator here, it's in the numerator here, and so it will cancel. And when we do that, we come up with 1,740 kilograms per cubic meter. And again, all I did was I did 1.74, this is divided by 1, times 1, times 1, divided by 1,000, times 100 cubed. And 100 cubed is 1,000,000. And then divided by 1, and I came up with 1,740. If I want to write that, keeping my 3 significant figures, I would write it as 1.74 times 10 to the third kilograms per cubic meter. And that would be the most acceptable answer. But this was a straight conversion. It wasn't necessary. It wasn't necessarily 3 significant figures, but I would feel safer writing it as 3 significant figures. Okay? All right. So let's find out how fast a bullet travels at 861.0 meters per second. Right away, we recognize that we've got 4 significant figures. This 0 is significant because it's to the right of a non-zero digit and a decimal place. So that is going to be 4 significant figures. So our answer has to have 4 significant figures. And we want to go, here's the how fast does it travel in miles per hour. So that is our X factor, miles per hour. So we're going to do this. It's a derived unit. This is going to be X miles. And in the denominator, we've got hours. And then we have our equal sign. And we go to 861.0 meters. And don't use a slash in this, as it's indicated here. My recommendation, whenever you have derived units, is to do a horizontal line because it's just easier to see your conversions if you do that. If you throw the slash in, I promise you it will throw you off. Now I'm going to give you another conversion factor for this one, just to sort of shorten the problem, and that is over here. I'll tell you that there are 1,609 meters in 1 mile, and so I'm going to avoid having to do what I did here, which is going from inches to centimeters, which would require me to go from meters to centimeters, centimeters to inches, inches to feet, and that's going to shorten my problem considerably. So I've got meters, and up here I've got miles. Miles is the larger unit, and so I have 1,609 meters per 1 mile. And so when I multiply across, meters will cancel. That's going to give me the numerator of my x factor, which is miles. Now all I have to do is go from seconds to hours, and I'm going to show you another shortcut. There are 60 minutes in 1 hour, and there are 60 seconds in 1 minute. So that's ultimately 60 times 60. So here we go. So 60 times 60 tells you that there are 3,600 seconds in 1 hour. So when I multiply and divide, seconds will cancel. That's going to leave me with hours. That's the denominator in my x factor. And so now all I have to do is plug it in my calculator, and it goes like this. 861.0 times 1 divided by 1609 times 3600 divided by 1 hour. And just plug it that way in your calculator. It'll work every time. It's a beautiful thing. 861.0, and that's times 1, and you don't have to put the times 1 because that doesn't change anything, divided by 1609, and then times 3600, and you don't have to divide by the 1 because that doesn't change anything. And to 4 significant figures, that gives us 1,926 miles per hour. And now you could do mph. So 1,926. That's how fast a bullet that's moving at 861.0 meters per second is going. All right, this is a really nice problem that we're going to do. It'll be the last dimensional analysis problem that you do. And the reason that this is a nice problem is you have to think about it. It's what we call a word problem. And it doesn't necessarily give you the conversion factors that you need straight up. You have to figure out what those conversion factors are. So drawing pictures is really useful when you are doing this kind of a word problem. If your lawn is 27 feet by 32 feet long, and each square foot of lawn accumulates 1,150 new snowflakes every minute, how much snow in kilograms accumulates on your lawn per hour? Assume the average snowflake has a mass of 2.23 milligrams. So that is a straight up conversion factor. One snowflake has a mass of 2.23 milligrams. So we can go ahead and just accumulate some knowledge. So one snowflakes, in this case, this stands for snowflakes, not significant figures, is equal to 2.23 milligrams. Now keep in mind, we're going to kilograms. You need to know your metric prefixes to do this work. All right, so what else do we know? 1,150 new snowflakes every minute. So every 1 minute, 1,150 new snowflakes accumulates on your lawn per hour. Oh, there's more. Each square foot of your lawn accumulates 1,150 new snowflakes. So here's another conversion factor. 1,150 snowflakes accumulate on every 1 square foot. Every 1 foot squared every minute. Every 1 minute. So that is an equivalence. 1,150 snowflakes on 1 square foot of lawn every 1 minute. I want it on the entire lawn. So I'm just going to draw a picture, and drawing pictures is very useful. So I've got a lawn. Here it is. And it's 27.0 feet wide, and it's 32.0 feet long. So the first thing I need to realize is that, and I'm going to do this out of scale. So here is my out of scale 1 foot by 1 foot, and this is just length or width times length, which is going to give me 1 square foot. And in that 1 square foot, 1,150 snowflakes accumulate every 1 minute. Okay, I actually think we have enough information. I guess all I have to do now is figure out, well, how big is my lawn? So X feet squared for the entire lawn, which is, that's actually what I'm interested in. So that's just going to be 32.0 feet times 27.0 feet. And that gives me 864 feet squared. That's for my entire lawn. Okay, that's the whole smash. So what I'm interested in, what my X factor is X, how much, that's the how much in kilograms per hour. So this is going to be kilograms of snow per 1 hour. All right, here we go. So over here, I'm going to put my 864 feet squared. I could put that over 1, and that's my lawn. So this is just 1 lawn, my lawn. I don't have to. It's not going to matter because that's what we're interested in. This is all about the lawn. And over here, I've got feet squared, but I have to remember this is every 1 minute. And then what's accumulating? 1,150 snowflakes. So when I multiply across, feet squared is going to cancel. Now I have on my lawn 1,150 snowflakes per minute for the entire lawn. Lawn is not going to cancel in this. But now I need to go ahead and convert minutes to hours. So minutes is in the denominator here, so minutes is going in the numerator here. Hours will go down here, and hours is the larger unit. It gets the 1, and there are 60 minutes in 1 hour. When I multiply and divide across, minutes will cancel. So here's what I've got now. I've got snowflakes per hour. Hours is in the denominator of my X factor. I'm done with the denominator because this is for the entire lawn. So now that I've got that, I simply need to convert snowflakes to kilograms. So 1 snowflake weighs 2.23 milligrams. Okay, that I accumulated here from the word problem. And so snowflakes divided by snowflakes will cancel. That'll give me milligrams. I need to go from milligrams to grams because I don't know how many milligrams there are in a kilogram, but I do know this ratio. In every 1 gram, which is the larger unit, there are 1,000 smaller milligrams. When I multiply and divide across, milligrams cancels. I'm now in grams. I simply have one more conversion to make. I've got grams in the numerator here, so grams will be in the denominator. Kilograms will go in the numerator. Remember, that's the numerator of my x factor. Kilograms is the larger unit. So kilo means 1,000, so there are 1,000 grams in 1 kilogram. When I multiply and divide across, grams cancels. That gives me kilograms in the numerator. That's the numerator of my x factor. All other units have canceled. So when I multiply and divide in my calculator, here's what I'm going to do. 864 times 1150 divided by 1, because this is 1 minute times 1 foot squared, times 60 divided by 1 hour, times 2.23 divided by 1 snowflake, times 1 divided by 1,000 milligrams, times 1 kilogram divided by 1,000 grams. And that's going to give me my answer. That's how I'm putting it in my calculator. And so I come up with 132.9 kilograms every 1 hour on the lawn. But to 3 sig figs, I'll go ahead and round up to 133 kilograms per hour that accumulate on my lawn. And that's how we do that.